Swayam Prabha. Digital India. Educated India.
Namaste and welcome to the video course on watershed management. Today in module 2 on sustainable watershed approach and watershed management practices, in lecture number 5 we will discuss about the agricultural practices and watershed management. So, the topics covered in today's lecture include watershed ecology and agroecosystems, soil and water conservation management practices, sustainable land management practices, crop management, nutrient and pest management, integrated farming, and finally a case study. Some of the important keywords in today's lecture include agroecosystems, agriculture management, nutrient and pest management, and integrated farming. So, as we discussed in earlier lectures, like sustainable water management or sustainable land management or the sustainability issues are all very important in watershed management. So, in any of the watershed which we consider, one of the important land use is the agriculture. So, we have to see what are the important issues as far as the agricultural management is concerned, what are the important issues in sustainable agriculture management. So, as far as watershed in many parts of the world are concerned, watersheds are experiencing pressure from high population growth, climate, land use change and over exploitations of natural resources. So, you can see the effect of population growth and then the land use change, all these are directly influencing the agricultural practices within the watershed. So, as we discussed earlier, to stop the degradation of natural resources and to understand the sustainable agriculture management practices, we need to deal with upstream and downstream resources management challenges. So, what are the major challenges within the watershed as far as various resources are concerned, how we deal with the management of those resources. Then the sustainable agriculture management is concerned, we have to deal with to identify sustainable land use practices, to increase sustainable agriculture production and to increase opportunity of rural livelihood. So, we can see that in most of the areas rural people are living mainly based upon the agricultural or the farm outputs. So, we have to improve this farm output in a sustainable way. So, for that on a watershed basis we have to see that the agriculture is sustaining and then the land use is sustainable and water use is sustainable. So, within that we have to see that how we can have better agricultural or agriculture water management or agricultural practices. So, let us see some of the issues as far as water management in agriculture is concerned. So, this deals with the interactions and interplay between food, people and nature sectors. So, we have already seen earlier when we discussed about the sustainability issues. So, the important sectors are food, people and nature. So, out of this the food sector produces biomass and influence ecosystem most of the time positively and sometimes negatively. So, we can see that as far as agriculture is concerned, the water is concerned, major use is consumptive. So, this is can be directly through irrigation or otherwise. So, as far as irrigation is concerned, there can be major or micro irrigation and many times farmers use excessive irrigation and say this irrigated water are largely recycled. Then some of the other issues like use of fertilizers and pesticides and then corresponding problems like non-point source of pollution in the water either surface or groundwater. So, like this we can see that agricultural water use is concerned, a large number of issues are there which we have to deal as far as the particular watershed is concerned or watershed management is concerned. So, you can see that when we consider the three sectors like food, people and nature. So, the requirement of water for the people is relatively small. So, you can see that say for example, if you can see 1 centimeter per hectare per day for as far as irrigation water is concerned, that much water is sufficient for 1000 people domestic or other usages. So, if you consider say the world average as far as agricultural, municipal and industrial water usage is concerned, the ratio is 70 to 15 to 15%. But say for example, in developing country like India, this usage is 85% for agricultural, only 8% for municipal use and 7% for industrial sector. So, that way you can see that say for example, in a country like India, major portion of the water is used for agricultural purposes. So, if we can save the water, available water say by doing appropriate agricultural management practices, effective water use in agriculture, then we can save a lot of water. So, but you can see that in most of the time whenever we consider the farming sector for a sustainable agriculture, we need irrigation, since as we discussed earlier, the rainfall is say distributed only for say 4 or 5 months. So, time wise variation is there, then spatial wise variation is there. So, that way we need irrigation for sustainable agriculture. So, that way if you consider say for example, the global withdrawal of water for agriculture, industry and municipal use, and then its total use in liters, say for example, the data from 1900 to 1995 for about 95 years, you can see that this curve shows the total withdrawal, and then you can see that this just below this curve shows the agricultural withdrawal, and the municipal usage is much smaller. This white line shows the municipal usage, and then this grey line shows the industrial usage. But especially in agriculture, a lot of water is lost in different ways. So, that way with respect to the total withdrawal, you can see that the effective water or the total water usage is much less compared to the total withdrawal. So, that way if we can save the water which we are using for agriculture by appropriate management practices, optimal irrigation management practices, we can save lot of water, and that can be utilized for many other purposes, and then also we can use say for example, for further irrigation and other purposes. So, if you consider a world average, the world average for irrigation is concerned, irrigated area covers about 40% of arable land in the world, and rainfed is the rest. That means about 60% of the arable land in the world is say the water is obtained through rain, and only 40% is obtained through irrigation. Say for example, now if you consider India's agriculture scenario and irrigation is concerned, so India has about 2% of world's land, 4% of fresh water, 16% of population and 10% of its cattle. So, this is the major issue as far as a developing country like India is concerned. We have got only 2% of world land, but we have 16% of population, and then 10% of cattle, and only hardly 4% of fresh water. And the geographic area is concerned, say India has 329 million hectare of area, of which only 47% is cultivated, 23% is forested, and 7% under non-agriculture usage, and about 23% of the land is wasteland. And if you consider with respect to the population, the land availability is concerned, per capita availability of land 50 years ago, that means in about 1950s it was about 0.9 hectare, but now due to the population explosion, this will be reduced to about 0.14 hectare by 2050. So, that way the land availability compared to any other country, it is much smaller. So, that way India has a major problem as far as the sustainable practices as far as land water and agriculture is concerned. So, whatever available we have to do it in a better way, and out of the cultivated area in India, about 40% is irrigated, which produces about 55% of the food requirement of the country, and 60% is rainfed, producing about 45% of about 250 metric ton of food required presently. So, you can see that 40% of the irrigated area produces 55% of the food, and 60% of rainfed area only produces 45% of the 250 metric ton of food produced. So, in 40 years, say for example, by 2050, government of India wants to increase the irrigation level such that we can have more food production. So, the irrigation we want to increase up to at least up to 50%, so that 50% is irrigated area and 50% is of the arable land is the rainfed area. So, that that ratio of food production 75% can be produced from irrigated land and 25% from the rainfed land out of the 500 metric ton of food required by 2050. So, this is the Indian scenario as far as the agriculture and irrigation requirement is concerned. So, now let us see what are some of the agriculture related issues as far as especially India is concerned. So, in India after the independence in 1947, there is a large increase in agricultural growth rate. Say for example, in the 1950s if it was about 0.3%, 60s and 70s or 80s it has increased to 3.5%. So, this has mainly happened due to a large number of irrigation or reservoir projects implemented in the earlier 5-year plans. So, that way the irrigation capacity has increased, and that way the agricultural growth has increased. So, and then another important issue is say in the first few 5-year plans, say in 70s and 80s, government of India put a lot of efforts to improve the agriculture sector through introduction of new high yielding varieties, that is say we can call it as first green revolution in 70s, and then in second green revolution say in 80s, government of India through its agriculture and other ministries concentrate on the genetic engineering through organized input management and say farmer services and extension, and then also better seed varieties were implemented in the agriculture sector. So, that way we can call this say 1980s as second green revolution. So, that way lot of improvement were taken place in the agriculture sector. But of course, lot of issues are still there in the agriculture sector. So, some of the negative trends in spite of the positive trends as we discussed here, the negative trends are say per hectare yield is low. So, compared to other countries like USA and China, the per hectare yield is much low. Then infrastructure facilities in the farming sector are concerned are poor. Then say the total management aspect is neglected in most of the farming sector. And then also you can see that still in rural area the farming is not mechanized. So, people are using different types of traditional equipments for farming, and then say most of the time the rural farmers are not adopting scientific farming. So, that way say lot of issues are there as far as the agriculture in India is concerned. So, some of the important constraint as far as agriculture sustainable agriculture in India are concerned are listed here. So, these are decline in per capita land availability. So, as we already discussed that per capita land availability is decreasing due to population explosion. Then stress in water resources. So, available water is not sufficient for irrigation due to lack of say better agriculture management practices, water management practices, or lack of availability of sufficient water. Then degradation of soils, the lack of efficient water management, monocropping. In many areas farmers are continuing with the same crop. So, that way there are a lot of problems as far as nutrient management and then other soil related issues are concerned. Then lack of crop management, negligence of sustainable agriculture. So, say as far as especially most of the farmers are concerned, they are not bothered about the sustainability issues as far as agriculture is concerned. And then of course, people's apathy, that means the farmers are indifferent to various the scientific farming or mechanization and other issues due to of course various other constraints, due to lack of availability of resources or due to lack of education and other issues. So, that way these are some of the important issues, especially in a country like India as far as sustainable agricultural management practices are concerned. So, now let us see the agriculture management practices within the perspective of watershed. So, we have already seen that agriculture practices are very important in any of the watershed management plans. So, the agricultural practices following within a watershed, whatever watershed plans or management issues we are making, so that will definitely affect. So, that way let us discuss about the watershed eco-hydrology and agro ecosystems. So, this agro ecosystems we can define as a subset of ecosystems that defines functional representation of coherent agricultural activity, including interaction of living and non-living components involved within the watershed. So, we are considering a subset of the ecosystems as agro ecosystems. Then we can do various zonation according to the ecology, according to agricultural practices and the climate system. So, that way we can call these zones as agro ecological zones, which are defined as land units carved out of agroclimatic zones based on major climate superimposed on length of growing period. So, if a particular crop is concerned, a particular say climate season is concerned. So, accordingly we can say define these agroecological zones. So, this mainly depends on the moisture availability. Say for example, India is concerned, we can classify India into 20 agroecological regions and 60 agroeco sub-regions. So, as we defined here, agroecological zones indicate the various issues as far as the agriculture is concerned with respect to land, with respect to climate and other issues. So, each agroeco sub-region has further been classified into eco unit at district level for developing long term land use strategies. So, when we discussed about the sustainable agriculture practices, these agroecosystem or agroecological zones are very important, since we can implement or we can sort out many issues by considering these agroecological zones or agroecological sub-regions as we discussed. So, here in this slide you can see the agroecological regions of India. So, these various colors indicate various zones. So, these zones are delineated based on physiography, soil, length of growing season and bioclimate of the region. Say for example, we can say the agriculture ministry has put various nomenclature also. So, for example, AER zone means say a zone is called AER zone. So, there it is numbered as A13 EH1. A stands for physiography, 13 stands for soil scale, EH stands for bioclimatic zone and 1 stands for length of growing period. So, that way we can put various agroecological zones. So, AER zone A13 EH1 is referred as Western Himalayas here. So, some of the important characteristics of these zones: shallow skeletal soils, hyper-arid climates with length of growing period less than 60 days. So, that way by considering these agroecological zones, we can look into various sustainable agricultural practices or issues, and then we can go for planning and management. It can be watershed based planning and management, but by considering this type of zones we can implement or we can have various plans. So, as we discussed, so what are the necessities or what are the need of agroecological classification? So, the needs are listed here to assess yield potentialities of different crops, crop combination in agroecological regions or zones, then to formulate future plan of action involving crop diversification, to disseminate agricultural research and agrotechnology to other homogeneous areas, and then to determine the crop suitability for optimization of land use in different agroecological regions or zones. So, as we discussed, so this agroecological region or zones say indicates say what kind of crops, say what kind of climatic region or what kind of soil pattern is there. Then we can put plants say like what kind of crops can be grown there, what should be the crop period length. So, like that various issue can be put according to the agroecological classification or agroecological zones or regions, and then we can come up with the plans as far as sustainable agricultural practices are concerned. So, now as far as sustainable agriculture practices are concerned, soil conservation and water conservation are two important issues. So, let us look into some of the important principles and issues as far as soil and water conservation are concerned. So, soil conservation important principles are based upon rainfall of high intensity, then erosion of top fertile soil takes place. So, we have to stop this soil erosion. So, that is by various practices we can reduce the soil erosion. So, that is the so called soil conservation. So, we can have various measures like contour farming, and then say we can plant trees or grass to reduce the soil conservation. So, various measures are possible, like biological measures like a conservation tillage, deep tillage, conservation farming, and we can go for mechanical measures like terracing, water disposal, other low cost measures. So, like shown here, we can say reduce the soil erosion, and we can go for soil conservation using various techniques. So, then as far as water conservation is concerned, the principle of the water conservation is say where precipitation is less than crop requirement, what we have to do. So, then where precipitation is equal to crop requirement or where precipitation is in excess of crop requirements. So, accordingly these three classes we can have a particular say intervention or particular strategy say according to the climatic or rainfall conditions. So, in the first case where precipitation is less than crop requirements, the strategy includes land treatment to increase runoff onto cropped areas, following water conservation, use of drought tolerant crops, suitable management practices. So, this is when the precipitation is less than crop requirement. Then second case where precipitation is equal to crop requirement. So, the strategy is local conservation of precipitation, maximizing storage within the soil profile, and storage of excess runoff for subsequent use. So, this is when precipitation is almost equal to what is required as far as crop requirements are concerned. And then the third case where precipitation is in excess of crop requirements, the strategy is to reduce rainfall erosion, to drain surplus runoff and store the surplus water for subsequent use in summer season. So, this way as far as water conservation is concerned, we can make particular strategy depending upon the region, depending upon the case. We can have either whenever precipitation is less than crop requirement, or whenever precipitation is almost equal to crop requirement, or when precipitation is in excess of crop requirement. So, accordingly we can go for particular strategy as far as water conservation is concerned. So, now based upon these issues, now let us discuss the sustainable land management practices. So, we have seen to achieve sustainable agricultural practices, we need to go for sustainable land management practices. So, sustainable land management practices that gives knowledge based, it is a knowledge based system which helps to integrate land, water, biodiversity and environmental management to meet rising food and fiber demands, while sustaining ecosystem services and livelihood to meet requirements for the growing population. So, we can define the sustainable land management like this. So, it is a holistic way of sustainable approach as far as land, water, biodiversity, environmental management and then say the requirement as far as the growing population is concerned. So, this sustainable land management or SLM enhances the productive capabilities of land in crop and grazed area. So, if you consider the various issues appropriately, we can increase the productivity, the crop yield and then forestry can be improved, or the grassland or grazed area can be improved. So, through sustainable land management we can have actions to stop reverse degradation or at least to mitigate adverse effects of earlier misuses. So, whenever we discussed about the watershed deterioration issues and related problems, we have seen that say here say the watershed will be degraded say by various problems, various issues as we discussed earlier. So, through sustainable land management practices we can at least reduce what is happening, and then also we can reverse the trend so that we can have say overall sustainable development. So, now let us look into what are the objectives as far as sustainable land management practices are concerned. Some of the important objectives are listed here: to increase land productivity. So, that means replenish soil nutrients by liming or other means, and then maintain soil cover. So, like cover, we can use cover crops and residue recycling. And second objective is to provide adequate quantity of water. So, there is no scarcity of water. So, we can use crop, forage or tree species with higher water use efficiency. So, that depending upon the available water we can go for say water resource management using particular crop. Then to maintain water quality. So, water quality is also an issue. So, here we can protect vegetative filter areas in the riparian zones to remove excess sediment and nutrients, and then also the non-buoyant source of pollutions, all those we can reduce. And then third objective is to reduce flooding and flood damage. So, as we discussed earlier, flooding is always a problem. So, we can through sustainable agricultural management practices or sustainable land management practices, we can plant a deep rooted vegetation to enhance infiltration and water consumption by the plants, and this also may decrease the soil erosion problems. So, these are some of the important objectives as far as sustainable land management practices are concerned. So, now let us look into the sustainable agricultural issues. So, first one is the crop husbandry. So, crop husbandry means the practices of growing and harvesting crops based upon scientific principles and careful management and conservation of resources. So, whenever the cropping pattern, so we have to consider the cropping pattern, what type of crop is to be used, then the various issues say as far as soil is concerned, water is concerned, and then the health of the crop is concerned. So, here the crop husbandry includes soil enrichment, usage of hybrid and improved seeds, and better cropping pattern. So, some of the techniques used for improved crop productions include soil enrichment by biofertilization, then introduction of micronutrient management, then usage of hybrid seeds, achieving optimum plant population, so that better production will be there. Then timely and effective weed control. So, we say in agricultural practices weed control is very important. So, we have to timely do the weed control. Then pest management. So, these are some of the important techniques which we can utilize in crop husbandry, so that we can achieve sustainable agricultural practices as far as various crop management or crop husbandry is concerned. Then the next issue in sustainable agriculture is nutrient management. So, as far as nutrient management is concerned, it is important to tackle problems like use of inorganic fertilizers. So, last few decades farmers are using lot of inorganic fertilizers like urea, then phosphates, like that. So, whenever we use without say optimal use or without scientific say knowledge, then what happens is that it decrease the soil fertility, and then also it become a pollution source as far as soil and water is concerned. So, then other issues as far as nutrient management is concerned, to stop weed growth, to avoid crop diseases, improve crop yield. So, these are the main issues as far as nutrient management is concerned. And then as far as nutrient management is concerned, it includes disseminate knowledge of nutrient and its function to plant growth. So, most of the time say in a country like India, the farmers are not well educated. So, we can disseminate the knowledge, say why we had to study a nutrient analysis as far as particular area, particular watershed is concerned, and then how to improve the nutrient say in the soil. So, we can disseminate the knowledge and then its function say in plant growth as far as nutrient management is concerned. Then assessment of nutrient availability as far as the watershed is concerned. And then nutrient management, like supply deficient nutrients to the soil, also avoid excess use to protect the environment. So, as I discussed, say for example, the nitrate, phosphate and then say potash, NPK is concerned. So, you can see that the last few decades many areas farmers are using this the important nutrients like NPK. So, what happens when it is overuse is there, it becomes an environmental problems, and whenever underuse is there, so then it becomes a deficient nutrient as far as the particular area is concerned. So, that way we should look into an effective nutrient management as far as the particular area or particular watershed is concerned. Then let us further look into the nutrient and its functions. So, there are two basic types of nutrients. One is so called macronutrients. So, these macronutrients are available in soil in larger percentage, say for example, nitrogen, phosphorus, potassium, sulfur, calcium, magnesium, etc. So, then other one is so called micronutrients. So, this is available in soil in minute percentage. So, like iron, copper, zinc, manganese, etc. So, that way this depending upon the requirement for the particular crop, say depending upon the availability of that particular nutrient for the particular area, we have to provide that particular nutrient to the soil, so that the crops can grow in a healthy way and it can give better yields. So, appropriate nutrient management is very important. Then let us look into what are the important functions of nutrients. So, some of the important functions are listed here. These are it include an involvement in photosynthesis and produces carbohydrates, then early root formation and growth. Then nutrient helps plants to survive in better environmental conditions, like if the environmental conditions like drought area or the increased saline area. So, like that, so the nutrients can help plants to survive in these particular areas. Then increasing water use efficiency. So, if you give appropriate nutrients, appropriate levels to the plants or to the soil, then we can even increase the water use efficiency. And then important role in reproduction of plants. So, these are some of the important functions as far as nutrient is concerned. So, we should have better nutrient management plans as far as the particular area or particular watershed is concerned. So, then say particular area is concerned, we should assess the nutrient availability, and then we have to provide nutrients to the soil for the particular crop is concerned. So, the various tests are possible as far as the assessment of nutrients are concerned. So, some of the important tests are listed here, like a traditional soil test, including tests like for pH, nitrogen, phosphorus, potassium, electric conductivity, etc. So, this type of test, traditional soil test, we can perform in every 3 to 5 years. So, that depending upon the non availability of this particular nutrients, we can provide these nutrients according to the requirements. Then another important test is so called nitrate test. So, this include the pre-plant nitrate test for additional nitrogen, deep nitrate test, how much nitrogen has already reached below the crop rooting zone. So, this test we can do, and then accordingly we can provide appropriate say nitrate treatment as far as the soil is concerned. Then next one is traditional plant test, like a chlorophyll meter to quickly determine the nitrogen status without destroying any plant tissues. Then also we can go for irrigation water test, and then electric conductivity and pH test. So, these are some of the tests used to assess the nutrients available for the particular area, particular soil for particular crop growth. So, then accordingly we can go for nutrient management by supplying appropriate nutrients on appropriate levels or appropriate measures to particular area for the given crop. So, now another important issue in sustainable agriculture management is pest management. So, the pest management, the main objective is to say how pest management interrelates with climate, water, crop and soil management, say for farmers to understand. So, the farmers should understand how the pest management will help them, then to incorporate this pest management techniques and its so its decision making process as far as the farming is concerned. So, this is another important issue. So, some of the important necessities as far as pest management is concerned that include a critical component of conservation practices. So, it is very important, the pest management, the negative impacts of pesticides. So, if overuse is there, then lot of issues can be there. Then ground and surface water deterioration due to non-point source of pollution like pesticide contamination. So, this is a very important issue as far as water and soil is concerned. Then environmental risk like say for example, burning crop residue for disease and then insect control. So, these are the necessities as far as the pest management is concerned. So, then for the considered area, considered crop, we have to go for appropriate pest management as far as the sustainable agriculture management is concerned. Then generally we use a term called integrated pest management, IPM. So, IPM approach is to pest control that combines biological, cultural and other alternatives to chemical control with the judicious use of pesticides. So, instead of overuse or underuse of pesticides, we have to judiciously use the pesticides by considering the various biological, cultural and other chemical issues are concerned. So, the important goals of integrated pest management include maximum use of naturally occurring control forces in the pest environment. So, particular area or particular crop is concerned, we have to consider whether we can control the pest naturally. So, if it is not possible, only we have to go for chemicals. Then first focus on non-chemical measures. So, whether biologically or with say natural control, whether we can reduce the pest. So, first focus is on non-chemical measures, then use of chemical pesticides only for preventing severe damage. So, as far as particular farm is concerned or particular agriculture is concerned, so we go for integrated pest management, so that to reduce of course the damages due to the pest, but we have to see that whether without non-chemical measures whether we can reduce the pest problem, and then if chemical measures to be adopted, then it should be in a controlled way, so that there are very less environmental problems, so that we can achieve sustainable agricultural management for the particular area is concerned. So, now finally, let us look into what are the important issues as far as sustainable agricultural management practices are concerned. So, some of the important issues are listed here. First one is biomass management. So, for the particular area, what kind of crop is to be considered for the particular region, particular area, depending upon the soil, depending upon the water availability, and also like crop rotation. Then second issue is concerned better conservation practices as far as land and water is concerned. Land and water are concerned, we have to go for better conservation practices. Then conservation buffers. So, for sustainable to achieve sustainable agricultural management, we can consider conservation buffers like forest buffers at particular area, then grassed waterway, then we can go for filter strip, then vegetative barriers, then conservation barrier for wind, etc. So, various conservation buffers we can consider for the particular watershed or particular area is concerned to achieve sustainable agriculture management. Then as we discussed earlier, we can go for crop husbandry by considering the various crop management practices are concerned. Then we can go for nutrient management. So, as we discussed in the previous slides, nutrient is very important. So, we should not overuse and we should provide sufficient nutrients as far as the particular area or particular crop is concerned. So, nutrient management is very important in sustainable agricultural practices. Then integrated pest management. So, first we have to see whether we can go for pest control without chemical use, and if chemical use is required, then we should go for on a scientific way, controlled way. Then of course, as far as sustainable agriculture practices are concerned, we can go for modern technology like molecular biology, then and genetic engineering. So, now these two branches of science like molecular biology and genetic engineering have been grown considerably in the last few decades. So, the scientific say availability of this molecular biology and genetic engineering or its practices, through its practices we can have better sustainable agricultural management. We can go for say for example, seeds are concerned, we can go for hybrid and improved seeds, and then we can go for tissue culture, we can go for say hybrid varieties. So, like that various things various due to the development in molecular biology and genetic engineering, we can use the various available techniques for sustainable agricultural or agriculture management is concerned. So, now another important issue in sustainable agriculture management is whether we can go for integrated farming system. So, say integrated farming system or IFS, some of the issues are listed here in this slide. So, say for example, mixed farming system, we can go for mixed farming system. So, mixed farming system combines crop and livestock enterprises in a supplementary and or a complementary manner. So, for a particular watershed or particular area is concerned, it is not only crop, we can have a integrated way of say mixed farming as far as crop is concerned, as far as livestock are concerned. So, we can combine together, so that we can have better say economical achievements as far as the watershed is concerned. So, integrated farming system means integration of various agricultural enterprises like cropping, animal husbandry, fisheries, forestry, etc. So that we can have better economical achievements as far as the particular area is concerned, and this gives great potentialities in the agricultural economy. So, some of the important components of integrated farming system include crops, livestock, birds and trees. So, depending upon the area, say for example, crop is concerned, we can have monocrop, that means only one type of crop, or a mixed or intercrop, and then multi-tier crops of cereals, legumes or pulses, then oil seeds, forage, etc. So, crop is concerned, we can have not only monocropping, we can have different crops together. Say for example, say wherever coconut farming is there, with the coconut we can go for say we can grow pepper. So, like that various crops can be combined within the given area, so that the farmers can have more products and better benefits from their particular farms. So, the main motto of integrated farming system is maximize food production and then overall development of a watershed. So, say by integrated farming we can achieve say overall development of the area, since the farmers will have say better profits since through various crops in the same area, so that we can maximize the food production and maximize the benefits. Then integrated farming system is concerned, some other say issues like intercropping, mixed cropping, strip cropping. So, as far as crops are concerned, we can have three ways of integrated farming. First one is intercropping. So, here crops are grown in space available in between the plants. Say for example, turmeric can be grown in mango gardens. So, like that, say some crops will be already growing like this. You can see that here in the mango garden, here mangoes are growing, and then here other types of crops. So, this is so called intercropping. Then second one is mixed cropping. So, here alternative rows of different crops we can use. So that say we can improve the crop yields, then preserve soil fertility. Then the third one is strip cropping, where long strips are used for growing crops on leveled beds. So, like this, as far as integrated farming is concerned, cropping is concerned, we can have intercropping, mixed cropping and strip cropping. So, like this say by using integrated farming system, we can achieve sustainable agriculture practices or sustainable agriculture management for the given watershed. So, within the perspective of what we discussed today, sustainable agriculture management practices are concerned, let us look into a case study. So, the case study is Watershed watershed is in Kothapalli village in Andhra Pradesh. It is spread over 465 hectares, and say an integrated watershed management plan based upon sustainable agriculture has been done by ICRISAT in this area. So, the details are taken from the ICRISAT website. Details are available in this website. So, the main objective of this watershed intervention was to link strategic research in natural resource management with the development research to increase productivity of rain-fed agriculture through enhanced efficiency of natural resources while maintaining the resource base. So, this was the main objective as far as the watershed intervention in Adarsh watershed. So, finally, through this the aim was to increase the productivity through adoption of improved soil, water, nutrients and pest management as far as the area is concerned. So, the area is shown here, it is taken from this website. So, the important strategy in this watershed was to link the research with watershed development schemes to enhance effectiveness of community participation. And in this watershed, a multidisciplinary, multi-institutional consortium approach has been utilized, and various developmental projects were implemented by CRISAT in this area. So, they used an islanding approach through micro watershed as upfront demonstrations managed by farmers with technical backups. So, technical advice given by CRISAT in this area, and then say the farmers implemented these projects. Then the watershed is concerned, on-farm strategic research was conducted by CRISAT in partnership with the farmers. So, some of the important watershed details are say 270 farmers, out of which in this area 136 are small land holding up to 1 hectare, and 60 are medium land holding, and 74 large land holding above 2 hectares. So, this were as far as the distribution of land holding as far as farmers are concerned in the Adarsh watershed. Then some of the other watershed details, like annual rainfall is about 800 mm, say 85% of it occurs during June, October. So, soils are predominantly black soils in this area. Soil depth varies from 30 to 90 centimeter. The general slope of the land is about 3%. And some of the important crops grown include sorghum, maize, cotton, sunflower, pigeon pea, soybean in rainy season, and sorghum, sunflower, vegetables in post rainy season under rainfed condition. And then in some areas say the farmers grow turmeric, onion and rice cultivation depending upon the water availability and then well irrigation. So, all these details were taken from the CRISAT website. So, let us look into what are the important interventions done by the CRISAT authorities. So, here they conducted a complete resource mapping as a first step, and then they identified the various problems as far as the watershed is concerned. They discussed the various issues with the farmers. So, some of the interventions done by CRISAT include continuous weather monitoring. They implemented a number of automatic weather stations in the regions, and then say conducted scientific soil analysis, so that soil, according to the soil analysis, the soil has been classified, and then they identified which type of soil is suitable for particular crops. Then also cropping system analysis has been carried out, so that how much crop yield is possible, then what is the cost for farming, and then what will be the benefits from the particular crop in the particular area. Then cropping has been done according to soil, then the cost effectiveness of particular cropping has been also analyzed, so that whether say better crop yield can be achieved through various measures. Then another aspect which has been implemented in this watershed is intercropping. So, we have already seen what is intercropping. It is not only one crop, various crops were say done in the same area. Then use of nitrogen fixing plants, so that say instead of providing say nitrogen through artificial fertilizers, so the nitrogen fixing plants give nitrogen to the soil. So, this has been implemented. Then vermicomposting, then organic farming. So, all those things were done in this particular watershed. So, also integrated pest control through natural control measures were implemented in this watershed. So, that was one another important aspect of the success in this watershed. So, then finally, the CRISAT or the NGOs carried out capacity building, and then they gave a training to farmers, so that farmers know what kind of cropping to be done and what particular area, and then say scientific way of farming, then by using soil testing, and then nutrient management, then integrated pest management. So, these are some of the important watershed interventions done in this watershed. So, now let us look what are the important impacts of these measures, interventions done by the ICRISAT in this Adarsh watershed. So, the analysis showed that crop yield considerably improved in many of the areas, then considerable improvement in water availability including groundwater. So, they implemented rainwater harvesting also in this area. So, that improved the water availability for the area. Then integrated nutrient and pest management were carried out. So, that way farmers are using very less artificial fertilizers, but they go for organic fertilizers, and then better nutrient management, and then they go for better say scientific pest control and natural pest control, instead of going for say chemical say using chemicals for pest management. Then continuous monitoring. So, as far as the watershed is concerned, it was monitored using remote sensing, and then GIS platform has been also used for overall better management. Then holistic watershed management, the holistic approach as far as land, water, agriculture and people are concerned. So, that way a holistic development approach has been say done in this particular watershed. Then this watershed has been declared as a role model of integrated sustainable watershed management through sustainable agriculture management by various agencies, and then so this has been replicated in many villages in India and abroad. So, another important aspect in this watershed is capacity building and training has been given by the NGOs to the people. So, people participation was another important aspect, and then overall socio-economic upliftment has been taken place in this watershed through various interventions. So, as far as this today's lecture is concerned, some of the important references are listed here, including various websites. Then based upon today's lecture, here I have listed one tutorial question. So, the question is illustrate necessity of sustainable agriculture management practices as far as overall watershed management plans are concerned. So, you can do through a systematic approach. Some of the steps are mentioned here. So, identify the components, then the possible scientific interventions as far as the agriculture management practice is concerned, then identify the problems, then identify the role of modern techniques like molecular biology and genetic engineering, then importance of nutrient management, then role of integrated pest management. So, most of these issues we have discussed in the lecture. Then some of the self evaluation questions from today's lecture are listed here. First one is discuss agriculture water use and compare world and Indian scenarios. Second question is what are the major constraints in achieving watershed based sustainable agriculture management. Then discuss the agroecological classifications in India and its importance. Then illustrate sustainable land management practices. So, for most of these questions the details are available in today's lecture. Then a few assignment questions: discuss Indian agriculture and irrigation scenarios, then explain watershed ecology and agro systems, then explain important issues in soil and water conservation, then discuss importance of nutrient and integrated pest management and related issues. So, most of these questions can be answered based on today's lecture. So, finally, one unsolved problem is listed here. For your watershed area, study the scope for integrated farming systems in your area. So, this we can do in a step by step procedure. So, first you can identify the suitable integrated farming system practices for the area for integrated sustainable agriculture management. then carry out stakeholder analysis, consider traditional practices of the farmers. You can go to the field and discuss with the farmers and identify, then suggest scientific methods, various methodologies how we can go for integrated farming systems, then identify soil and water conservation measures for the area, then identify proper monitoring and evaluation strategies for the area, and involve how we can involve the local people to achieve integrated farming systems for the given watershed. So, this is you can do it as an unsolved problem. So, this is today's lecture. We discussed about the sustainable agricultural management practices and then its importance in watershed management. So, we will discuss further the various issues as far as sustainable water management or sustainable watershed management issues are concerned in the next lecture. Thank you.